Hi, this is Professor Farouk Al Omari from University, and I'm presenting to you today the Informatics 2 course, starting from the first lecture, which talks about files. What we're going to cover in this class, in this course, is file handling in C, file access rules, file access functions. We're going to see what we're going to cover in these, in each one of these items. Handling files in C. C language communicates with files using a new data type called file pointer. We're going to talk about pointers later on in details, but at least for this particular file pointer, it's part of the standard io.h, so when we start, we have to include this library function. And it's written as file with all capital letters, as you see, and then an asterisk. A file pointer, let's say output file, which is going to be a variable, is declared in a statement like file, again with all capital letters, asterisk, output file. This is the variable, and this variable now is of this type, and it's going to be a pointer to a file, as we're going to see later. All right, now how to access the file. A user program has always to open a program before it can be accessed, as the file is something like if you are locking it inside a cabinet. So in order to access that file, you have first to open the file, and then you can read, write, do whatever you like for that file. How to do that? In C, well, we're going to be using a function that's called ifopen. One word, ifopen. So this function of open is going to return then the pointer for the file you're trying to access. If the file can't be opened for any reason, then the value null is going to be returned. And we're going to elaborate on this null pointer later on. On the other hand, if the file is opened successfully, then the file pointer is going to point to a structure that contains information about the file. Among this information is actually the content of the file, the data you're trying to access. So part of that information is the location of the file in the buffer or in the memory, basically. The current character position in the buffer. Basically, when you open it the first time, that pointer is going to be pointing to the first character in that file. When the file is being, whether the file is being read or written, and that's going to be, we're going to elaborate on this in a moment, because when you open it, you say, I'm opening it to read something from that file, or to write something to the file, or to do something else. And whether end of file has been encountered or not, and this EOF, end of file marker, it's a character, a special character, and we're going to see this in a moment as well. Okay, how to open a file using this ifopen function. So the syntax for ifopen. To call this function, we're going to use a statement like this. Out file, and that's a variable. We declared it ahead of time, equals to ifopen, and that's a call to this function. And this function takes in between two arguments named name and mode. What is this name first? It's a character string containing the name of the file. So you have to provide to this ifopen function the name of the file you're trying to access. And then you have to tell why you're opening this file, how you're going to access it. So in this mode, we're going to have a special character which tells whether you're trying to read data from this file, or you're trying to write to this file, or you're trying to append this file, or something like that. So this mode could be an R, and that's opening a file for reading. It could be a W for writing to this file. It could be an A for appending this file. And appending a file means to add data to that file. And that's different from writing to the file. In a sense, when you open a file with the W, you're going to be erasing all the data inside the file, and you're going to have the file pointer pointing to the first entry in that file. Whereas, if you want to add data to the file and keep the original data, all data in that file, then you have to use the letter A instead. All right. Some systems actually distinguish between text and binary files, and that has to do with the way data and characters are physically stored inside the memory. There's the what's so-called Little Endian and Big Endian architectures, and I assume you folks are aware of that. So that means the order in which data is stored in the file. In characters, you take them as they come. Whereas if we're talking about binary files, then you could have a binary number that consists of not necessarily just 1 byte, but rather 2 bytes, 4 bytes, if we're talking about integers, floating numbers, and stuff like that. And then the arrangement of these bytes within the memory could be different. And if you want to read carefully these, then you have to open these files as binary files rather than as text files. So for opening files for binary accessing, we use the character B. So in the mode, then we can combine actually 2 characters and not just 1. The first, which says R for reading, W for writing, A for appending. If you use that character only, then it's by default assumed that you're opening it or accessing that file, assuming it's a text file. But you can say something like RB, and RB, like if open. So we're at something like if open, open parenthesis, the file name, and this is something we talked about already, and then in here, the first character for the accessing the file, and then another character, and this is the new thing we're appending in here. This R is for reading the file, and this B in here is assuming that the opening of this file is to access it as binary data. And actually, we recommend to do this whenever we don't know what is the system we're trying to access the file from. Okay, so then after that, we're going to use, this is the whole syntax of the statement. Usually, instead of just saying if open the file and so forth, I want to make sure that we're opening the file correctly. And how to do that? Simply, we're going to use an if statement, which we know from the C language. So I say something like if output file equals to if open W for writing equals to null. And that means if the return value of this if open function comes to null, and that's a non-fruitful opening of the file, if you like, then there is an error. I could not access the file for some reason, and that's why I will print something like cannot open the file. Otherwise, the file has been opened successfully, and I can proceed with accessing that file. And now, what are the rules for accessing the file? We have opened it successfully, and now we want to move on to access it, read the data, write data to it, and so forth. If the file does not exist, and you're trying to write to it or appending to it, then that's no big deal, no big problem. A new file is going to be created for you as long as there is a space on the memory. Opening an existing file for writing, for a W, that means the old content is going to be destroyed, and I already told you that. While opening it for appending, preserves the contents. And that's the difference between the W, basically, and the A. If I attempt to open a file for appending, that means I'm preserving the data. And this is very important, and I'm repeating this because it's actually important. Trying to read a file that does not exist, however, is a problem. A return value of error is going to come to you. You cannot read from a file that does not exist. Of course, that file has to be created ahead of time, and then you can access it after that, and this is something logic. In that case, a null is going to be returned to you, and that means your attempt to access the file is not fruitful. Okay, we open the file, we access the file for reading, writing, appending, whatever, and now I'm done with the file. What do I do after that? Do I leave it? Definitely no. You're going to close the cabinet when you access the file cabinet yourself, right? You're not going to keep it open. And that's why we're going to close the file we already attempted to access. And the function for that is the if close, like that. Okay? And it's very important to close the file after you finish with that. This is usually done so that the pointer can be used for other accessing, either for files or something else. And this is important because otherwise that pointer is going to be stuck for that file and it's not available and it can't be used. This is one thing. And for another thing, the file you opened and you left open after you leave, yes, the operating system is going to try to close it, but maybe the file is not going to be appropriately closed after you leave the system and your data could be harmed. So it's a must, although it's possible not to do that, and there's no complaints from the compiler, but it is a must as a professional programmer always to close your file after you're done with it. As a matter of fact, as I said, the operating system is going to try to close the files you opened and you didn't close yourself. However, the system has a maximum limit on the number of files that it can handle, open, and close by itself. And for that, it is your responsibility as a programmer and not to leave that duty for anybody else, whether the operating system or anybody else, to close the file. So there is a maximum limit on the number of files that can be opened simultaneously, and it's a recommendation to close, and this recommendation is a must as a matter of fact, to close all these files after you finish the accessing for these files. Closing a file would be something like this. We use the function if close, and then just the name of the file pointer. It's very simple, very straightforward. If files are still open, when a program exists, when the program exits, the system will close them. But don't count on this. I'm telling you, you have to close your files as a good programmer, as a professional programmer. You have to do that yourself and don't rely on the system to do it for you. Okay. Input and output using file pointers. We have opened the file. And now, how one can use it for either inputting or outputting. C supplies sets of functions to allow users to do this. That is, to read from that file and write to the file or append data to that file and so forth. Some of these functions are very similar to the actually reading and writing from the standard input, standard output. That's from the keyboard and from the screen. So, these functions would be something like put character, and then between two parentheses, this put character actually puts a character to the screen, and actually in this case, put C a character, put this character C to the standard output. That's an equivalent statement to this one, okay? So whether we say this or we say this, it's equivalent. And in both cases, we're putting this character C to the standard out, and the standard out actually is the screen of the computer. However, this doesn't have to go always to the screen. Sometimes you want to write it to the file, and that's what we're trying to get to. Another function that we have is to get character. And this is, the syntax for that is get char, between two parentheses, C. Then you're going to input a character from the keyboard here and send it to the computer, to the memory. And it's, the character C is going to hold this character you enter from the keyboard. And this is equivalent to get character C from the standard input. And the standard input is the keyboard in this case. Okay? That's the standard input and standard output. Getting characters from the keyboard, putting characters to the screen. Do I want to do that always? No. What we're talking about is getting characters from the file that we have already opened, or to put a character to that file which we opened for writing. Okay. there are other functions that we use in C, like printf and scanf. And again, printf and scanf is to display a character on the screen, and scanf, as you all know, is to read a character from the keyboard, the standard input. They're the same, and you already know that from Informatics 1 course, I assume. The equivalence of these two functions when it comes to reading and writing from files are actually these two functions. Instead of just printf, it says fprintf, and f for file. So this basically is to put a character into this file after that file has been opened successfully for writing. And when we say if scanf, this is to read a character from an already opened file for reading. The functions are actually used in the same way we use the original scanf and printf in accessing the standard input, standard output. However, there is an extra parameter that we have to introduce in here, which tells me where to put this character or where from to read that character. So the syntax for that is this function returns an integer. And this integer is just something to tell you whether that function has successfully done whatever you asked for or not. So basically, you're going to say if scanf file pointer, and this is, in our case, in this example, is fp. So I have to tell him where to read from. And so he's going to be reading from fp, and fp is already defined to be of type file pointer, and this file pointer already has been opened for accessing in this manner. And then you're going to tell him where, when you read that character, where to put it. So you're going to put it in this variable. Plus other parameters which are extra, and we can elaborate on them later on. And you can refer, of course, to the website to see more details about this. For the if print, and that's to write to the file, you write to file pointed by pointer fb, and then this is the character you're trying to put. Formatted input and output with strings. Of course, you can always read 1 byte, the way we've seen it already, or you could read or write strings of characters. And that's very similar to get string and put string in standard C for inputting and outputting strings from and to the keyboard and display. In this case, they're called sprintf and scanf for string. So this is for putting a string into a file, and this is for reading strings from the file. So the sprintf then puts formatted data into, which is a string actually, into that file which we already opened. This can be done using the declaration as an array of character, and we're coming to arrays later on. And the data is formatted according to a control string of the same form as that of the printf. So pretty much we're talking about the same format in here. For the scanf, and that's to read a string of characters from an already open function, it takes that data. Again, it's an array of characters, and it's arranged somehow inside the file, and you're going to read it as a structure from there. So this is done in the same way that scanf is used. However, scanf is only from the keyboard, to where scanf is common from the file which we already opened. This is very useful for converting strings into numeric values, and in many applications, as a matter of fact, I save the data as strings in my file, but when I read them, I need to read them as integers or as floating point numbers, so I need to make the conversion from the string to numeric formats and vice versa, and this is applied in many applications, as a matter of fact. And topics like these have been covered thoroughly in the Informatics 1 course, the C programming. There are some special characters, invisible characters, that are used when it comes to file accessing in C. Actually, we have seen some of these. Basically, the null pointer, which we talked about, the EOF, or end of file character, and there are many other characters. The null pointer. The null pointer or character, that is an error return when we use the if open or the if close, or when you attempt to read from the file, or when you attempt to write to a file and that operation was not successful. In that case, the return value for these functions is going to be this null pointer. So this null says operation was not fruitful, didn't like it. The other special character is the EOF, or end of file. This is a very interesting character. Actually, it's not visible. You can't see it when you physically open the file, but it's a special character that's appended to the end of the file after you enter all the data you like. So that's a marker to you when you read characters from that file. So you're going to keep reading data till you encounter this EOF character. And that's a marker that the file is finished. It's all the data has been read from that file. Null is a pointer value or a character. If a pointer, then the pointer variable does not reference any object. And that means we're pointing to nothing, basically. And that's if I refer to null as a pointer. This is usual for functions which return pointers, as a matter of fact. So if my function returns a pointer, I'm assuming when I use that function to return some pointer to a file or to something in the structures that I have. Now, if that operation was not successful, then I'm going to receive a pointer which points to basically nothing in the memory. And that pointing to nothing means pointing to null. So it indicates to you that your operation was not successful. So I always have to check for that. And we already did this, actually, when we opened the file. When we said if open that file equal null, that means returns a null, my operation was not successful, so I returned an error statement. The return value of these functions can be tested for decision making, and that's the if statement we're saying. Null is returned by read commands of the getString family, getString or getCharacter, putCharacter, and stuff like that, when they try to read beyond the end of an input file. So if I try to read from the file and that file does not exist, or I have come to the end of that file, then the return value is going to be definitely null. Where it is used as a character, the null is commonly written as /0. /0, this is a character, as a matter of fact. We don't see it, however, we inherently, implicitly use it. And that means typically in C, as you have seen in Informatics 1 course, in strings of characters, this special character always terminates any string, as a matter of fact. So the last character physically, the last character in every string is a /0, basically a pointer, and that indicates the end of the character. However, we don't see this character, but we use it by C to check for the end of that character. So that's the way we use null as a character. It is the string termination character, which is automatically appended to any string in a C program, and that's what we're saying. Usually, the programmer needs not to bother about this thing. It's implicitly added by C. So you always check for it. You don't have to write it at the end of your string, and that's done by the C language compiler automatically. The end of file, it's a marker. It's a special character again, an invisible character, which indicates the end of a file. It's returned by read command like getCharacter or scanf when it tries to read beyond the end of the file. I reach the end of the file. I'm attempting to read. No more characters to read. I'm done. So the return value from the get character or scanf is actually end of file. So again, we're going to be using the decision-making statements, basically like the if statement, to say something like, if get character from this file equals null, then there was an error. There's no more characters to read. Otherwise, else, okay, you get the character, and then you can access it, process it the way you like. Let's take an example which summarizes all these rules and all these issues we talked about so far. And this is pretty much the last thing we're going to talk about in this class. In this example, we want to write a program that concatenates two files together. I have two files. Hopefully, they're full of data somehow. And I want to concatenate these two files. Concatenation means to create a new file. And in this new file, I'm going to take whatever data in the first file, put it in this new file, and then append it with the data coming from the second file. Okay? All right. So we're going to be writing something like this. This is a comment, and you know this from C / cat, and this function is to concatenate files. The main function takes basically two arguments, and these two arguments basically tells me where these files are. And so this is going to be a pointer to the names of the files. And this basically this integer tells me how many arguments I have in here. Let's see how that goes. First, I'm going to define a file pointer of type file asterisk. And that means if P is a pointer to a file. And that's basically is going to point to the files I'm trying to open and concatenate. And I'm going to be using a function called file copy that takes two pointers to the two files I'm trying to copy or to concatenate together. Okay. And then what I'm going to do now is I'm going to check what is the number of arguments I'm having in here. If argc equals to 1, and that means no arguments whatsoever, then that tells me that I'm trying to to copy whatever I get from the standard input, which is the keyboard, to the output. So the files, virtual files that I'm using are basically the keyboard and the screen. So in that case, use this function and copy whatever you get from the standard input to the standard output. Otherwise, if the argument is something else, and that means I have files to read and write, then let's go to the next slide and see what we're going to do. While minus argument c greater than 0, that means I'm going to be reading these arguments, which are actually the files I have in consecutive. What I'm going to do each time, I'm going to open the argument v, and that is actually the name of the file. Open that file for reading. I'm going to read from these files consecutively. But hey, we're not going to be reading it right away, but rather I want to make sure that I'm opening that file successfully. So that's why I said if the if open statement equals to null, then there is a problem. So the file cannot be opened. However, this statement is successful, then I go here. Okay? And in here, I'm going to copy the file, which is pointed already by fp, to the standard output. So whatever data I'm getting from the file pointer, okay, and that's the file I already opened for reading, and sending it to the standard output, which is the screen. So pretty much I'm displaying the content of that file on the screen, and I'm done with that. I close the file. So I say if close fp and return 0. The return I've used here returns 0, and this is a successful return. However, in here, I said return 1, and I made this return right after a failed attempt to open the file. Okay. what is the file copy? How do I now copy from the first file to the second file, whether it's standard input to standard output, or the FP, which I already opened, to the standard out, or anything like that. It's a simple function. Okay, so this file function, file copy, is going to return a void, nothing basically. And basically it takes the, as we said, the two arguments, the IFP pointer, which points to the input file, and the OFP, which points to the output file we're going to send the data to. We're going to define in here a local variable of type character, C. So pretty much we're going to reading from the input file to this character, and then we're going to take this character to the output file. To do that, I'm going to start with the while statement to go through all characters in the input file. And pretty much what I'm going to do in here is to get a character from the input file, put it in the character variable C. And in here again, we're checking to make sure that it's not the end of file character. So I say, while I'm reading from this file, putting it in character C, and this does not come to an end, then please put this character C to the output file. So pretty much this statement reads from the input file, and this statement in here puts this thing or this character to the output file. And that's pretty much the function. Pretty simple, pretty easy, and straightforward. We're going to go back to the standard in, standard out. As I said, standard input to the computer is basically the keyboard or the scanner sometimes. And the standard output is this display, the screen of the computer. The file pointers, standard in and standard out, are actually objects of type file. So pretty much these standard in, standard out are actually pointers to special type of files, if you like, the keyboard and the display or the screen. They are constants and not variables. So I cannot change them, as a matter of fact. So it's not possible to assign anything to them. Okay, so now what if we want to input and output a whole line using file pointers? There are actually equivalents to the put string and get string functions when it comes to files. For that, the equivalents are if get string and if put string. These two functions are pretty much equivalent to these, except that they're talking to files rather than to the standard in and standard out, which we just talked about a minute ago. The programmer should be careful in using these two functions, as a matter of fact, because they're incompatible with the standard get s and put s functions, where this incompatibility is. Actually, there is the first thing, which is the maximum number of characters that have to be read. In these two new functions, we have to specify this maximum number of characters, which is unusual to the put string and get string standard functions. And one more thing is that this if get string and if put string, they retain the trailing new line character. You know, in C there is this new character thing /n. Okay, when it comes to the put string and get string functions, the standard functions, these two special characters /n do not exist, and they're not part of the string, whereas they are part of it in this case, and that's the incompatibility, as a matter of fact. So we have to be a little bit careful when dealing with these functions or these two sets of functions, and when we use them interchangeably. So when transferring data from files to standard input and standard output channels, we have to be careful about this incompatibility. So the simplest way to avoid this incompatibility with the new line character, we use if get string and if put string for the files and standard channels too. So if you decide to use these functions, then you have to use them for the standard input, standard output at the same time, so that you avoid this incompatibility of this new line special character at the very end. So for example, To read a line from the keyboard, we would say something like if getString, and we're using this new function now. In this case, we have to specify one more parameter in here, which determines the maximum number of characters, which was not there in the standard getString function. This data string points to the data string itself, and it goes to the standard, coming from the standard input. And to write a line to the screen, we use something like if putString, dataString, and standard out. Okay, so that's it for the files. I guess just to summarize what we have covered today, basically we talked about files, how to access files using C. And for that, we have talked about three main things in here. Number one is how to open a file for accessing. Number two, how to access that file once it's opened. And number three, what to do after we finish the accessing. Going back to number one, we have seen the functions on how to open a file for accessing. And anytime you need to access a file, you have to open it first. As a matter of fact, you have to specify why even you're opening the file. And the answer for that, are you opening it for reading? Are you opening it for writing, for appending, or whatever, as we have seen during the class? Class is open successfully, file is open successfully. Then after that, you have to use the functions to read characters from the file or to put characters to the file. Depends on the way you opened it and why you opened it, and so forth. You read whatever data you want, you wrote the data you want to the file, you're done with the file, then you have to close the file after you're done with it. And it's very important to close properly the file using the ifClose function we have seen. This is very important. Before, as a professional programmer, before you leave and exit your program, you have to close all files that you have opened. And this is very important. Yes, we said the system is going to close these files after your program exits, but you don't, as a professional programmer, count on this. You have, as a programmer, to close all files that are opened, because there is a maximum limit on the number of files the system can handle. This is one thing. And the other thing, there are no guarantees that your files are going to be closed properly once your program exits. And that's why it is a must for a professional programmer to close his file. This is pretty much what I want to cover in this class. If you want to see any more details, definitely you can go in the internet to the UNINETTUNO website, and you can click on the MidNetU. Thank you very much, and I'll see you in the next class.